Okay, everybody, let's take a look at a recap of today's lesson. So what we're trying to do is get to polynomials that we can factor and graph. But before we can do that, we need to go back to factoring. So I went through the different types of factoring. The first type we talked about was common factoring, and if you can common factor, meaning can you find something in common, a common multiple, a common whatever. But if you can, only if you can common factor, it makes the problem easier. So common factor is usually a pretty good thing to do if you can. So I looked at this example, 5x cubed minus 10x squared minus 40x, and I thought, well, if I common factored out of 5x, then it should make it a smaller problem. In fact, I took out a 5x from 5x cubed, I got x squared. I took out 5x out of 10x squared, made it 2x, and then out of 40x made it an 8, and I realized, wait a minute, this trinomial here, that can be factored. Multiples of 8, negative 8 that make a negative 2. So I went parentheses, parentheses, which is a trinomial, and then I went x and x, negative 2, positive 2. So this entire polynomial, I made it easier by common factoring out 5x, and then I was able to factor the trinomial into x minus 4, x plus 2. So here's my entire factoring. So then again, we talked about trinomial. If it's 1, 2, 3 terms, if it's a trinomial, we always do parentheses, 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 parentheses. 3 terms, trinomial, parentheses, parentheses. We've got x times x makes x squared. Negative 4, positive 2 makes a negative 8. And we can always check the middle term, which is the negative 2x, by doing what I call the double smiley. Double smiley checks the middle term, negative 4x, positive 2x, which checks the middle term, okay? Now, one that we don't talk about much, and that's difference of squares. Difference means subtract in math. Difference means subtract. And a square, well, square numbers. 25, 36, 64, let's see, 4, 9, all sorts. So I have an x squared minus 25. That's a square term minus another square term. It's just going to be x times x plus 5 minus 5. Okay? Because there's no middle term. But it has to be minus. If you have an x squared plus 25, it won't work. It can't be done. We tried to see how it could be done. Cannot be factored. Okay? It has to be minus. Now, here's another one. We can even make them big, but it's super easy. A perfect square, subtract another perfect square. 2x, 2x, minus 5y, plus 5y. But this one with the plus can't be done. It needs to be a minus in the middle to be difference of squares. Okay? Then, we talked about grouping. If you see 4 terms, 1, 2, 3, 4 terms, if you have 4 terms, then what you can do is you can group them. It has to be an x cubed, some cubed, and 4 terms. We group them. The first 2 together, second 2 together. We looked at these and said, what do these 2 have in common? Just group them. Pair them up. Pair them up. These first 2 have in common an x squared. If I take an x squared out of both terms, there's 3 of them. Take out 2, I'd have an x. Take an x squared out of this term, I'd have a 7. These next 2 have a multiple of 4 in common. So factor out a positive 4. I need the plus there. Take out a positive 4. And what I have left is a x plus 7. 4 goes into 4. 4 goes into 28. And then I can common factor this again. Now they both have a parentheses x plus 7. So I can common factor out what they have in common. There's my x plus 7. I pull it out of both. And what's left over? Well, if this is gone, what's left over is the x squared plus 4. You could double check it if you want to. Okay, so those are all the different styles of factoring that we like to do. So then we took that information and we applied it to our book. So what we want to do in our book is really come up with some ways to graph. So we looked at page 292 and we looked at what Colt did. So again, I have 1, 2, 3, 4 terms. So I'm going to do it by grouping. So 4 terms, x cubed, we're going to do it by grouping. So I put the first 2 together and the second 2 together. So what was the first step? We common factored. This one we common factored out an x squared. The second pair we common factored out a negative 1. Now that's an invisible 1. We common factored a negative 1. We need the negative there. If these two are the same, we're on the right track. So the second step is we common factor out what they have in common, which is a parentheses x plus 3. If we take out the parentheses x plus 3 from both, we're left with an x squared minus 1. Now, sometimes we can factor again. Sometimes we can factor again. And so the x squared minus 1 can be factored into an x plus 1, x minus 1, difference of squares. Now, these two expressions are the same. It's just one is factored out, and the original is the polynomial expression. So, if I wanted to graph this, I need zeros, right? So I take it and I set it equal to 0. I already have my mini equations, and so I have an x plus 3 equals 0, gives me a negative 3. X plus 1 equals 0, gives me a negative 1. X minus 1 equals 0, gives me a positive 1. And then these zeros are also x-intercepts. Sorry about that. Bring it up. Solve my mini equations, negative 3, negative 1, and 1. These are going to be my zeros, which are also my x-intercepts at negative 3, negative 1, and 1. And I know from end behavior, that's a positive, so it must end going to infinity. So I know it has to take off to infinity from here, so my graph looks something like this. Okay, so we factored the trinomial. We got many equations. We found the x-intercepts or the zeros, and we graphed it. Okay. Now again, if we look at problem number 5, same type of problem, except for slightly different. Again, we saw 1, 2, 3, 4 terms, an x cubed, so we did by grouping. In the first group, they have an x squared in common. I took out an x squared. Out of the first two terms, I have an x plus 7. Second term, I took out a negative. I took out a negative 4. I need that negative 4 there because it becomes a subtraction. Okay. So then I take out a negative 4 and I have an x plus 7. 4 goes into 4, 4 goes into 28. Then I notice the x plus 7 they have in common. So I pull out the x plus 7. What's left after I take out the x plus 7 is an x squared minus 4. Again, sometimes we can factor again. Sometimes we can factor again, and in this case we can. X squared minus 4 becomes an x plus 2, x minus 2. And then, if I'm looking for a 0, I set it equal to 0, and I get my zeros, which are also x-intercepts at negative 7, negative 2, and positive 2. Those are my x-intercepts at negative 7, negative 2, and 2. I know end behavior. It's a positive x cubed, so it has to go off to infinity. So I can make my graph go off to infinity, but it has to go through my zeros, back through my zeros, back through my zeros. Okay? Now, the next one that's a little weird is Braxton factored this. He did by grouping. He got to here. And I told you you guys can't factor this. So what do? Well, we went to mini equations. So this is where it gets weird. We have an x squared plus 4 equals 0. It does not factor, but we solve for it. All right, minus 4, x squared equals negative 4. So we took the square root, but you can't take the square root of a negative number. So we talked briefly in class about the fact that the square root of negative 1 is I. Okay? It's just anytime you take the square root of negative 1 or a negative number, you're going to get I. I is an imaginary number. So you see that. It's an imaginary number. So to make this easy, I broke up this number, plus or minus because there's two answers. Plus or minus because there's two answers. But I took negative 4 and I wrote it as 4 times negative 1. It's going to make it really obvious why. Negative 4 at the same time as 4 times negative 1. So the square root of negative 4 is the square root of 4 times the square root of negative 1. And then I have the square root of 4 is 2. And this we learned, square root of negative 1 is I. So there's my two roots. So how this works, again, you have this one. No, let's not forget the x plus 2, which gives me a root of negative 2, which is here. It has an imaginary, so it's going to go through. It does its little bumpy. Somewhere are my imaginaries. Okay. Now on the back, we did one last problem, and we saw that if it's an x to the 4th, but it's still a trinomial. It's still a trinomial. So I know if I'm looking for zeros, I'm going to have 4 zeros. I'm definitely going to have 4 answers. Has to be 4 answers because of the x to the 4th. And I knew if it's a trinomial, I went parentheses, 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 parentheses. Okay? x squared, and then negative 9, negative 1, because the negative times negative makes the positive, but they add up to make the negative 10x squared. So then this one factors again, x plus 3, x minus 3, and this one factors again, x plus 1, x minus 1, or vice versa. And then I get my zeros. I get my zeros at 3, negative 3, and 1, negative 1. So these are my zeros, which are my x-intercepts. So I put them down. I've got a 0 at negative 3, negative 1, 1, and 3. I knew from end behavior it's got to go off to infinity. So it's got to shoot off to infinity, and it just goes through my intercept, through my intercept, through my intercept, and through my intercept. Okay? And that's all we had, and the homework was page, I think it was 297, 298. Okay? And then we said we'd wait on 5 and 6 for me to look at 5 and 6 together. Okay? So that's all I have, and I'll see you tomorrow.